We are here taking a look at Maple, and we're going to see some examples of some vector fields. So we've gone ahead and put in the with plots command, which lets us use this field plot and field plot 3D. So I went ahead and typed in what vector fields we're looking at. So the first one is f of xy is y squared I plus sine xj. So when we type out the field plot command, we put in our vector as an array, and then we indicate what we want x and y to go between. So this two-dimensional vector field, then we can see its graph, which is pretty cool. So as you can see, these vector plots on here, they show the vectors both with their length and their direction, so we can see the magnitude of those different vectors. And so what we really get to see is this picture of sort of the flow of those vectors. So we can see that there's sort of this strong movement where it's very strong in the beginning, and then it kind of carries on down and weakens a little bit, and then it swirls around and back up and then back out. And as you get closer to the origin, the magnitude of those vectors is very small, to where at 0, 0 it is the 0 vector, which is because if we plug in 0, 0 into that y squared I plus sine xj, that would be the 0, 0 vector. So that's an example of a two-dimensional vector plot, so a vector field in 2 dimensions. And then I want to look at a 3-dimension one. So I've got f of xyz is xi plus zj plus yk. So we put in the field plot 3D command with our vector as an array, so xzy, because those were our components from our vector. And then we've got the x is, we'll just went -2 to 2 for all the commands. And then this grid command just tells Maple how many vectors to plot. So this is going to be a 3-dimensional vector field. So we'll have a space picture here, and then we can see these 3-dimensional vectors, and you can see the little arrow pointing in the direction that they're going in. So they're kind of curving downwards and then back up, and this way they're curving outwards. If we want to see more vectors, we could increase these numbers here. So we could instead say make all of these 10s and then re-enter the command, and now we have a lot more vectors. And we could make this picture a little bigger if we needed to see it, but we can kind of see the directions of each of these. So we kind of have this flow towards this top corner, and then another, depending on where you start for other points, they sort of flow towards this bottom corner, which is pretty neat. And then just look at one more 2-dimensional vector field. This was the one that we were working on drawing on the board. So the vector field of y comma -x. So we did some examples of this, so then I just wanted to show you what a more complete picture of its vector field would look like. So we can see here that, let me see if I can move this picture down a little bit. So we've got, again, we see we had found those level curves of the magnitude, so finding places where all the vectors had the same magnitude really happened in these concentric circles, and so you can kind of see that motion here. So the circle at the very beginning, if you just have the point at 0, 0, you have the 0 vector, and so then the magnitude of circles with very small radii are very, very small magnitude vectors, and the further out you get, the larger the magnitude of the vectors are. But they do have this circular pattern to them, and it has that clockwise rotation to those vectors, which is pretty cool. So then the next thing I wanted to show you was, again, I kind of mentioned that there was that idea of sometimes people use these vector fields to represent different real-world properties. So I wanted to go to a little picture of a wind map. So this is an example we talked about in class. But so what this does then is each of the vectors sort of represents the direction the wind is moving in at that point on that place, that specific location, and then the magnitude of the vector would be the velocity or the speed of the wind. And so then you can kind of see this flow pattern of how the wind is moving and changing in different regions and different areas. So just some cool pictures and applications of vector fields to help us get a little bit better of a picture of them. Oftentimes it is far easier and more useful to use technology to graph vector fields, just since it helps to have a lot more vectors to see a larger scale picture of what's happening, as opposed to just having a few by hand sketches, though we did see how we could sketch it by hand in theory.